Hello, this is Kai from the University of Sydney. Here is some result for field solar eruption. This small flare occurred near the solar disk center. The subside of the active regions shows sunspot motion. We can find the rotation of the lower left spot and the strong shear flow between the top and middle spot in the right panel. This shear flow built energy of this active region and drove the small flare. Here is the observations from the AIA EUV measures. It's very clear to figure out at the initial stage, some brightenings occurred at the foot point of the flux rope, and then the rope experienced a sudden rise and then stopped. We modeled the field eruption by a data-driven simulation, which is initialized by a nonlinear force-free field. Three different popular methods give similar results and are comparable to the observations. All of them give three flux ropes and they twisted with each other. Observed solar ferric magnetogram are used to drive the simulation, and also the bottom plasma velocity is inverted by using the dive-for-VM method. They're filled into the ghost layer to drive the simulation, and then we use the open source code MPI-MWalk to solve the full MHD equations with the solar gravity and optical thin relative cooling. From the simulation, only the top part of the twisted structures shows a sudden rise, and the lower one seems very stable. This structure seems to correspond to the stable structures in the AIA 304 channel indicated by the blue arrow. Comparison between observations and the simulations shows some corresponding features. For example, the twisted and the fibrillary structures from the H-alpha in the top panel. In addition, the quasi-substrate layers at the bottom correspond to the observed flare ribbon in H-alpha observations, especially the spiral one, which is a typical Hawk structure around the foot point of the flux rope. Several ball patches are found in the simulation. Their reconnections correspond to the H-alpha brightenings. The brightenings number 1 in H-alpha observations come from the magnetic reconnection at this ball patch. The number 2 come from this ball patch, and we can also find a current sheet whose magnitude is indicated by the color in the left image. The brightenings in number 3 comes from the magnetic reconnection at this ball patch. The three brightenings indicate that the initial magnetic reconnection occurred at several different ball patches during the initial phase of this field eruption. The final stage in the simulation gives highly mixed and twisted structures in this active region. The color in the left figure indicates the magnitude of the electric current. It's clear that the final stage still contains multiple flux ropes, and the right one shows the same structure, but the color indicates alpha values. This value is a local index for the magnetic chirality, which is clear that the different twisted field lines are contained in the final stage. Here is a brief summary of our research. Thanks.